Okay, so same problem as the last one, but now instead of a drop kick, instead of kicking it from a meter high up here, it's going to kick it from the ground. So instead of having this 1 meter from the ground displacement in the y direction, what's my new displacement going to be? 0. Starts on the ground, ends on the ground. That's a lot easier to deal with, right? So let's go ahead and plug that in. 0 meters in the y direction. Switch markers, this thing's starting to burn out. Okay, so now we're asking for maximum height. Okay, so now we're doing a little bit different problem. We need something right in the middle here. Time of travel, range, the velocity vector at the maximum height. So we're going to need to know velocity in the x direction and the y direction at that maximum height. And then acceleration vector at that maximum height for x and y. All right, so a few different things that we're going to solve for here that we haven't solved for before. Just to get a little bit further understanding of what we're doing at that peak. So the ball travels over this distance. First of all, let's start filling in some variables like time. Once we find time, we can find range. So we'll have solved for these two. Then we can go through, find that maximum height. Then we can start figuring out what's happening down here. All right, so first of all, my initial velocity. The ball's kicked at a 37-degree angle at 20 meters per second still. It's just not a meter high now. So that 20 meters per second remains up here. Boy, this marker is not great either. Let's try green. All right, so my 20 meters per second remains up there. My VIY will be over here. My VIX will be down here. So there's my vertical component of initial velocity. Here's my horizontal component of initial velocity. Solving for the opposite side, which trig function do I use? Sine. Sine. 37 degrees. You guys just solved this for the other one, so you should be okay on these. VIY over 20 meters per second. What's my VIY end up being? Same as the last one, 12 meters per second. Same for VIX, except they use cosine. 16. Solving for VIX, I get 16 meters per second. So I have my VIX, my initial velocity in the x direction. I have my initial velocity in the y direction. Things we already know. Accelerations. What's my acceleration in the x direction? 0. We're discounting air resistance. Acceleration in the y direction, approximately? Negative 9.8 meters per second squared. I have a displacement in the y direction. 0. What's my final velocity in the x direction? 16 meters per second. Now, final velocity in the y direction, I can actually know in this case. Negative 12, absolutely. It started out at 12 meters per second. In this case, it goes up the exact same distance that it goes down. So whatever its initial velocity is, its final velocity will be the same thing, but in the opposite direction. That's why the negative. All right, so now I can go through, I can solve for time. I can use that first equation if I want to. However, I also have negative 12 for my final velocity, so if you want to, you can use the last equation as well. Which one would you like? What? Numero uno. Let's do it. All right, so my dy, 0. Here, let's write the equation up here so you guys know what I'm talking about. dy equals diy times t plus 1/2 a y t squared. So now, plugging in, my displacement in the y direction is 0. My initial velocity is 12. I'm solving for time. All right, so I'm left with time as my only variable. That's good. So 0 meters equals 12 meters per second times t plus negative 4.9 meters per second squared times t squared. What can I do with this chunk? Add it to each side. So I end up with 4.9 meters per second squared equal, whoops, times t squared. That's the whole chunk. Equals, what do we have? 12 per second times t. I can divide both sides by t. T will cancel out over here. One of my t's cancels out over here. Leaves me at 4.9 meters per second squared times t equals 12 meters per second. I can divide 12 divided by 4.9 gives me 2.45 seconds. All right? So when I divide each side by 4.9, my meters cancel out, one of my seconds cancel out, leaves me in seconds. All right, 2.45 seconds. Now that I have a time, I can easily solve for range. Remember, my range is very easy in the x direction because I have no acceleration. We're discounting air resistance. We're simplifying things for the sake of this unit. All right, so this same equation, but my acceleration in the x direction is 0, so that takes care of that. So all I do is multiply initial velocity of 16 meters per second times my time of 2.45 seconds. Seconds cancels out, leaves me in meters.
39.2.
Yeah.
39.2, okay. 39.2 meters. All right. So there's my distance in the x direction. Notice it's just a little less than the one in the last problem because I had that extra meter for it to fall, in which it moved also in the x direction. All right, so just a tiny bit less, 39.2 meters. Next question. First of all, we have maximum height. It takes 2.45 seconds to get over here. How long did it take to get to the maximum height? Half of that, right? 2.45 is 1.225, yes. All right, so my new time (1.225 seconds). Now, I'm going to find a new displacement in the y direction. It's going to be my maximum displacement. It's going to be how high it is when this 1.225 seconds expires. So from here to here, I'll have a displacement because I'll have a difference between my starting point and my ending point. My acceleration stays the same, right? My initial velocity is going to stay the same. So I can go back to this equation again, this time in the y direction. Change the y. So this time, plugging in, I'm solving for dy. Diy is 12 times time, which is 1.225 seconds. Remember, don't use your original time. Keep it at that half time. You want to end up right here. You don't want to end up over here. Plus 1/2 times negative 9.8 meters per second squared times 1.225 seconds squared. We're getting there. So, I multiply 12 times 1.225 gives me 14.7. So let's put it down here. dy equals 14.7. Seconds cancels out, leave me in meters. Plus 1.225 seconds squared. Multiplied by negative 4.9 gives me a negative 7.35, and that'll be in meters as well. And look at that, that's exactly half of that. So I'll end up with a Vy 7.35 meters. Make sense? All right, so the ball will go up at its maximum height of 7.35 meters. Now, last couple questions. Velocity vector at the maximum height. What's the velocity in the x direction at the maximum height? What's the velocity in the x direction the entire time? 16 meters per second. It starts out at 16 meters per second. It remains at 16 meters per second the entire time. So the Vx, we'll just call it Vx at this point, is going to be still 16 meters per second. The Vy, sorry. All right, the Vy, it starts out at 12 meters per second. What happens right at the peak? It's a 0. It slows down, it gets to 0, and then it starts accelerating in the negative direction. So my Vy, 0 meters per second. Now, last question. Acceleration vectors at the maximum height. Acceleration in the x direction. What's the acceleration in the x direction the whole time? 0. What's the acceleration direction, the vector in the y direction the whole time? Gravity doesn't change at that point, so I'm at negative 9.8 meters per second squared. So those last two questions, really not very difficult. We really don't even have to go through any equations to solve them. They're conceptual questions, really. We know that at the peak, it's at a 0 velocity because it's getting ready to head back down. We know that its x velocity stays the same the entire time regardless. Feel good about that one? Yeah. Excellent.